right, so I want to take a few moments to talk about this relationship here. So the sum of yi times xi minus x bar equals the sum of yi minus y bar times xi minus x bar. Now, a lot of times when I am deriving least squares estimators, I get to a point where I have this, and then I say, you know, that's exactly the same thing as what this is. So let's go ahead, and this is more convenient to use, so I just kind of use it and move on. But I don't ever slow down to kind of show this relationship, okay? So I want to take a few moments to kind of talk about why these two are equivalent, all right? So let's start with looking at what we see here on the right-hand side, and we're going to prove that it is equal to what you see here on the left-hand side. Okay, so first thing I want to do is just go ahead and distribute this yi and this y bar, and we're going to multiply it by what you see here in parentheses, xi minus x bar. Okay, so let's see, we have equals the sum from I equals 1 to n of yi. All right, I'm going to leave that xi minus x bar in parentheses, okay? So I'm not completely foiling, right? I'm just kind of distributing this first part of the sum, or this first part of the product, okay? So then I have minus, because that's minus y bar times xi minus x bar, okay? All right, so once I've done that, I've distributed that. Let's go ahead and bring our sum into each piece, right? So I have the sum from I equals 1 to n of yi minus xi minus x bar minus the sum from I equals 1 to n of y bar xi minus x bar. Okay, so if you notice right here, this piece is, this is what I want to get to, right? Let me use, let's see, I'll use pink. This is what this is, right? These guys are the same. So basically what I need to do is show that this piece here, it must be equal to 0, right? And then if I show that this piece here is equal to 0, then this relationship will hold true, okay? So let me go ahead and do that. I'm going to bring this over, okay? So I don't have to keep on writing this first piece over and over again, right? I basically need to show that this is 0. And then you'll believe me that this relationship is true, okay? So y bar does not have an I on it, right? So it's basically like a constant, so it can kind of be pulled out of the sum. Okay, it's like a constant. It can be pulled out of the sum. All right, so now let's go ahead and put our sum into each piece here. Xi minus the sum from I equals 1 to n of x bar, okay? Make sure you have parentheses so you know that y bar is being multiplied by that entire sum. All right, once again, now x bar does not have I, okay? So, but you're summing it up n times. So when we sum it up n times, we'll end up with n of them minus n x bar, okay? If you sum up the same thing over and over again, you're going to end up with however many of them that you summed up, which is n. All right, so now what is x bar? Let's go ahead and plug in the formula for x bar, which is the sum of xi divided by n, from I equals 1 to n. That's what x bar is, all right? So you might be starting to see what's going to happen here. These guys cancel. All right, so I'm left with, let me change my color back. This equals y bar, the sum of from I equals 1 to n of xi, minus the sum from I equals 1 to n of xi. All right, and of course these are exactly the same thing. So I end up with y bar times 0. Okay, anything times 0 is 0. So I have shown that this piece here equals 0. And if it equals 0, then I've shown that this relationship is true. All right. All right. Thanks for watching, and I hope that this clears up why it is that I just go ahead and go from here to here. And what's interesting about this is the same thing works. Suppose if this here, instead of it being yi, if it was xi here, this would be xi times x bar. So basically this also is true. Okay, so you can kind of show that using the method I just discussed, and you can work from there. You can also, of course, you can change all these x's to y's, and it's also true. Okay, so this is a nice little thing that we use a lot when we're talking about least squares estimators. You'll see us kind of use this relationship often. All right, thanks for watching.